There are three methods for proving triangles similar that we're going to be using. The first method is called angle-angle similarity, and it states that if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So you can see in this picture, they have marked the angle at J matching the angle at X, and the angle at K matching the angle at Y. So those triangles are similar by angle-angle. You have to name them in corresponding order so that they are matching just like when we were naming congruent triangles. And this symbol for similarity is right here in the middle. It looks like a squiggle, basically. Here we're going to do problem number 1 to decide if these triangles are similar or not. If you look at one of the triangles and use the fact that the angles add to 180 and subtract the two that we have, 180 minus 71 minus 78 leaves you with 31 degrees for the remaining angle. And since angle Q will be matching with angle G and angle R will match with angle F, these two triangles will be similar by angle-angle similarity. And we do need to name them because it says if they are, write a similarity statement. So we're going to name them. The first one, I'm just going to call it QPR. You can name them in any order for the first one. And then you just have to match that order. Since Q matches with G, G will be first. And then angle P would have to match with angle H. And angle R matches with angle F. So QPR similar to triangle GHF. Here's problem number 2. Same kind of problem. If I were to use this bottom triangle and subtract 110 and 27 from 180, I would get that this remaining angle would be 43 degrees. And since 27 matches with 27, but 43 does not match with 53, then these are not going to be similar because Q here, if we solved for Q, we would also see that it does not match with G. So these ones are not similar. For number 3, it says to show that triangle BCD is similar to triangle EFD. We're going to start with saying that angle C and angle F are right angles. And that's given. I'm going to say given. Not a lot of room on here. Sorry, I'm having to make my video a different way than normal. And I'm going to say that angle C is congruent to angle F now because all right angles are congruent. And then I'm going to go on and say that these angles here, these vertical angles are congruent. So I'm going to say angle CDB congruent to angle FDE, vertical angles congruent. And now I'm going to say that the triangles are similar. So BCD similar to triangle EFD by angle-angle similarity. The next one says a lifeguard is standing beside the lifeguard chair on a beach. The lifeguard is 6 feet 4 inches, should say tall, and casts a shadow that's 48 inches long. The chair casts a shadow that's 6 feet long. How tall is the chair? You could draw this in different ways. The key online has the beach chair and the person where their tip of their shadow lines up, and the picture looks like this one that I just drew. Or they didn't necessarily say that it had to be that way. It could be standing far enough away where the chair and the shadow are alone, and then the guy in the shadow are alone. So you could have any of these two pictures, and they will be similar by angle-angle. And then we're going to set up a proportion to solve here. The lifeguard standing beside the chair. Lifeguard's 6 feet 4 inches tall. So he's like standing here, 6 feet 4 inches, and casts a shadow that's 48 inches. The problem with this is that the person and the shadow need to have the same unit. So 6 feet 4 inches is 76 inches total. So we might convert the person's height to 76 inches. Then the chair casts a shadow that's 6 feet long. We want to know how tall is the shadow. So here's like the shadow there, or the beach chair. We have the shadow. We want to know how tall is the chair. And so online they converted the 6 feet into inches, which you can do. It would be 72 inches. But, as long as the chair itself had height in feet and shadow in feet, you could put the height over the shadow and it'd still be okay. But I'm going to go with the key from online. So we have the person's height at 76 inches over 48 inches. And then we have the chair's height, which right now, this X will be in inches since I'm doing inches over inches. 72 inches. If I had done, instead of 72, if I had done 6 feet, then X would be in feet. When we cross multiply and solve this, we get that X is 114 inches. You can divide that by 12 inches to see how many feet, and then how many inches are left over. If you divide this, 12 goes into this evenly 9 times, and then there's 6 inches left over. So the chair is 9 feet 6 inches or 114 inches. Just 2 ways of writing that. Another method we can use is side-side-side similarity. If the corresponding side lengths of 2 triangles are proportional, then the triangles are similar. You have to check all 3 sets of sides and make sure they reduce to the same thing. Side angle side has one angle matching and the sides that surround that. So ZX and XY, and then PM and MN surround those angles. Here it says which of the 3 triangles are similar. So we would have to be comparing the corresponding side sets. And if we look at this first one and we're reducing, and when you do this, you do need to put them in order. I like to start with the short leg length or short side length, and then medium side, and then long side. So the first triangle we have here is 38 for the shortest, and then 42, and then 54 for the longest. And then the one below there, the shortest is 30, and then 35, and then 45. And when you reduce the first fraction here, you get 19 over 15. When you reduce the second one, you get 6 over 5. And when you reduce the third one, you get 6 over 5 as well. So since the reductions of these fractions do not match, the first and the second triangle are not similar. So the problem with the first triangle is mainly the short side, which is this 38. So that's going to help us when we want to figure out which one would need to be changed. Let's compare the second 2 triangles. Again, I'm going to put them in order. Small to large, 30, 35, and 45. And then it'll be 18, 21, and 27. And when we reduce, we get 5/3, and 5/3, and 5/3 for each of these. And since these do match, they are similar. The scale factor would be 5/3 if they'd asked us for the scale factor. So I am going to name the similar triangles. I'm going to say P, Q, R. P was between the medium and the long leg, so I will need to start with Z. I went from P to Q across the long leg, so I need to go from Z to X across the long leg, and then to Y, so those are the similar triangles right there. And then to fix says what value would need to be changed in the triangle to make the triangle that was not similar to make it similar to the other 2. would be to change this 38 to a 36, and then they would be similar as well. Right here, this is the last problem. It says show triangle JKL similar to triangle LKM. I'm going to do that by using the sides. I'm going to help myself by kind of writing out my similar sides in a proportion. JK are the first two letters, LK are the first two, so those should line up. Then KL should line up with KM. And then first and last, JL should line up with LM. And so JK in the picture is 49. LK in the picture is 28. KL, same as LK, 28. KM is 16. JL is 56. And LM is 32. So I set up these proportions again using the names from the similarity statement is how I figured out my corresponding sides. And I wrote proportions with them, and now I'm just going to reduce those proportions. The first one will reduce to 7 over 4. The second one will reduce to 7 over 4, and so will the third one. So since they all reduce to 7 over 4, they are similar by side, 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 similarity.